right, so we've got the notes for section 3.4, which is the properties of logarithmic functions. So there are a couple of rules we've got here. So product rule just states if you're multiplying two quantities together, you can split them into separate logarithms separated by an addition sign. Usually these two rules are actually used in reverse. Usually you use them to combine two logarithms, because if you're going to solve, you have to have a single log term. Quotient rule, if you have division, you separate with subtraction, or if two logs are being subtracted, you can combine them with the division problem. The power rule just states that if your term has an exponent on it, you can pull that exponent out like a coefficient. Now, if you notice, these are all the same base, log B, so I can't do like log 2 and combine it with a log base 4. That doesn't work. They have to have the same log or base. Okay, so example 1 says assuming x and y are positive, to write log 8x y to the fourth as a sum of logarithms or multiples. Okay, so the first thing we're going to do is we're going to use our properties to break it apart because of multiplication. So we have 8 times x times y to the fourth. So that's going to be log of 8 plus log of x plus log of y to the fourth. So that's using the product rule. Things that are being multiplied can be separated with addition. Now there are no quotients, so I don't have to worry about this rule, but I do have an exponent, so I can use the power rule. So log of 8 plus the log of x plus 4 times the log of y. So the exponent, that's the rule. All right, example 2, assuming x is positive, to rewrite the natural log of, okay, so let's rewrite this guy real fast. X squared plus 5 all over x. So the first thing we have to take care of is that quotient, which means we separate with subtraction, so minus ln x. So that's taking care of the quotient. Now the square root is the same thing as a half power. So I'm going to rewrite it like this. Half minus ln x. And now I can use the power rule. So that exponent comes out front, 1/2 ln x squared plus 5 minus ln x. And that's actually as far as you can go. You can't do anything with this because we don't have a rule that breaks the sum apart. And it's not two separate logarithms, so I can't combine it. This logarithm doesn't distribute. Okay, right. Natural log of x to the fifth minus 2 ln xy is a single logarithm. Okay, so we are going the other way now. So we are undoing all of our rules and combining them. Okay, so undo any coefficients can be rewritten as exponents. So that would become this. Logs that are separated with subtraction were originally a division problem. So the natural log of x to the fifth for xy quantity squared, which is the natural log of x to the fifth over x squared y squared, which is the natural log of x cubed over y squared. Now notice this natural log is out front. It's not on top with the x to the fifth. It's an operation on that whole thing. All right, so change of base formula. This lets us do logarithms that are not log base 10, the common log, or log base e, the natural log, in our calculator, because your calculator only has two buttons. It has regular log, the common log, and ln, the natural log. So here's your formula. You can also actually do this one. If you want to use natural logs, it actually works just the same. You can use any base you want. Usually we use the common log or the natural log because our calculator has those buttons, but you don't necessarily have to do it if you don't want to. So to do the common log, so I'll use common log. So the common log of 16, which is always the big number, divided by the common log of 3, and that literally can just go in your calculator and numbers come out. Log 16 divided by log, 3 would give me this. So that's about 2.52. And if you want to check, if you do 3 to the 2.52, you get about 15.9. So pretty close because we had to round. So this one would be the log of 10 divided by the log of 6. So that's actually going to be 1 because I used the common log, but you don't have to. So log 10 divided by log 6, so 1.29. So 6 to the 1.29 will give me 10. This one would be the log of 2 divided by the log of 1/2, and this would be -1, if you work it out. Log 2 divided by log 0.5, -1. Now this one we could have actually done the old way, 1/2 to what power is 2. 2 is the same thing as 1/2 to the negative 1, so we will get the same answer. Okay, so using the change of base formula, you can rewrite any logarithmic function, log base b to the x, as some multiplier of a logarithm. So describe how to transform the graph of ln x into the graph of the given function. So we're going to rewrite this. So this would be using change of base to be ln x over ln 5. And then we're going to rewrite that so that we have our constants. So it look like this. So what this is that's a vertical stretch. So it's a vertical stretch of whatever 1 divided by the natural log of 5 is. Like, I'm not going to work it out. I don't care. Some goofy decimal. So this one would be the natural log of x over the natural log of 1/4. So this would be, okay, let's see here. Whoops, arrow. 1 over ln 1/4 times ln x. So this would be a vertical stretch of 1 over the natural log of 1/4, which is actually, we can probably actually do this something else. That's 4 to the negative 1. So this is 1 over the negative ln 4, if you want to take the exponent rule into account. So if stretching by the natural log of 1/4, we'll actually do a x-axis reflection because of the negative sign that appears, and then stretch of 1 over the natural log of 4, which will give you the same thing if you do that. If you graph these two equations, they will be equivalent. And that is the end of that section.